This looks like ordinary paper. But tilt it, and part of the bill actually moves. The strange part is, this isn't simply an image printed on top. Creating that feature is only one part of a much larger manufacturing system.
And the security begins before the first major image is printed.
Federal Reserve notepaper is made from a cotton and linen blend, with security fibers built into it. The first major printing stage adds the detailed background colors.
Here, color isn't enough. Every layer has to land in exactly the right place.
But the most recognizable parts of the bill require a completely different printing method.
Intaglio printing presses the paper against engraved areas under extreme pressure, leaving raised ink behind.
And now the sheet looks like money. But it still isn't finished. The next stages are where the individual notes begin becoming uniquely identifiable. Now comes the final printed layer, the one that gives each note its official identity.
Letterpress adds the serial numbers, along with the Federal Reserve and Treasury seals.
At this stage, you're still looking at a sheet, not individual bills.
And now the factory has a new problem, finding anything that shouldn't be there.
Printed sheets are inspected, so defective notes can be separated from the good ones.
But some of the most important security features aren't really visible until light passes through the note.
A watermark can create a faint image within the paper itself, visible when light passes through. Nearby, another security feature is embedded directly into the paper, the security thread. Under ultraviolet light, that thread glows pink, adding another layer of authentication. And that's when the bill reveals something even stranger. A security feature woven into the paper actually appears to move.
Tilt the note, and the bells change into hundreds. Tilt it again, and they change back.
That's because the ribbon is woven into the paper, not simply printed onto it. Then there's another trick. The lower right 100 changes from copper to green when the note moves. It's a visual change designed to be noticed with a simple movement of the note.
But adding security features isn't enough. The factory has to prove they're all correct.
Automated inspection systems examine printed sheets for defects before they're processed further.
Machines do the heavy inspection work, but trained people remain part of the quality control process.
If a sheet doesn't meet the required standard, it doesn't move forward with the others.
Only after inspection can the large sheets move toward becoming individual notes.
The bills now look finished, but the factory still has one crucial question to answer. Are they all perfect? At this stage, the printing is largely complete. Now the focus shifts to final processing and control. High-speed equipment handles, counts, and organizes the finished notes with remarkable precision. And even in a highly automated operation, people remain part of the final chain of control. One of the oldest security technologies is surprisingly simple. Texture you can feel.
The raised printing gives genuine notes a distinctive feel that isn't captured by appearance alone.
Then there are the serial numbers, part of the note's official identity. Different features reveal themselves under different kinds of inspection. Paper, ink, thread, watermark, texture, optical effects. Each layer adds another checkpoint. And that's the real secret. The security isn't one feature. It's the combination. A genuine bill has to survive all of those checks at once. And we're about to see what happens after production ends. Once production and processing are complete, the finished currency leaves the printing operation and enters the financial system. From there, genuine notes can eventually travel through banks, businesses, and everyday transactions. And now every security feature has a new job, helping people and machines recognize the genuine article. Modern currency equipment can also examine notes using multiple characteristics. And that's why the strongest protection isn't hidden in one place. Different features become useful under different conditions, creating layers of verification.
So why build so many layers into one piece of paper?
Because defeating one feature wouldn't be enough. A genuine note carries several independent signs of authenticity.
What began as specialized paper has passed through printing, inspection, processing, and layers of security engineering. The goal isn't to make a bill that looks complicated. It's to make authenticity much harder to fake with a single trick.
Before the journey is complete, the finished notes still have to pass through controlled processing and quality checks.
At this scale, consistency becomes an engineering problem of its own.
The smallest details matter, because authenticity is built from all of them together.
What looks like one simple bill is actually the result of multiple layers of materials, printing, inspection, and engineering. But here's the part that's easy to miss. None of these features works alone. Together, they create a layered system that can be checked in different ways. Under ultraviolet light, the security thread gives inspectors another visible signal.
And some checks don't require a factory at all. Even ordinary handling can reveal visible security features.
So the real achievement isn't one impossible feature. It's how many layers have been engineered into one small note. And that's what makes the modern $100 bill so difficult to reproduce convincingly. Authenticity is built into the entire object.